All right, next up, we've got the graph of f of x is equal to 2x to the 5/3 minus 5x to the 4/3. What is this, a strange polynomial? No, it is not. I don't know about you, but I haven't a clue what this graph looks like. So to get us started, why don't we go ahead and find its domain? Okay. Well, we've got roots in here because this is a cube root. That's also a cube root. What can you take the cube root of? You can take the cube root of anything. Positive numbers, negative numbers, 0, which means the domain here is all real numbers. Of course, it wouldn't have been if this was an even root. We'd have to make it only just greater than or equal to 0. But hey, this one is an odd root, which is all real numbers. What's that mean for us? It means we have no holes or vertical asymptotes. That's a handy piece of information. All right, and now let's consider its intercepts, shall we? Okay, so we've got, where is x equal to 0? I mean, if x is equal to 0, what's y equal to? So I'd have f of 0 is equal to 2 times 0 to the 5/3 power minus 5, 0 to the, it doesn't even matter, it's equal to 0. So we've got 0, comma 0 is our y-intercept. And at least one of our x-intercepts. It's possible we have more than one x-intercept. Let's check it. The way we check it, of course, is just set the whole thing equal to 0. 0 is equal to 2x to the 5/3 minus 5x to the 4/3. Did I write that down correctly? I know that you will tell me if I didn't. Okay, how am I going to solve this one? How about, since it's equal to 0, we try factoring. So what can we pull out of this? We're going to pull out the smallest factor of x, which is going to be the 4/3 one. So I'd have x to the 4/3, boop, boop. And now let's just divide everything by x to the 4/3. I'm going to do this right over here in the margin. X to the 5/3 divided by x to the 4/3. Subtract the exponents. 5/3 minus 4/3 is positive 1/3. So I get 2x to the 1/3 minus 5, since x to the 4/3 is what I pulled out of this thing. Okay, we get x is equal to 0, which we already knew, and we also get 2, scribble, we get 2x to the 1/3 minus 5 is equal to 0. Add the 5 over, divide by 2, and then cube everything. So x is equal to 5 cubed, which is 125, over 2 cubed, which is 8. 125 over 8. Okay, I'm not real sure what that is exactly in terms of a decimal. 125 divided by, that isn't correct. Where's my go back key? There we go. 125 divided by 8. 15,625. All right, so we've got 15.625 comma 0. Let's put these points on our graph, huh? We had the origin, and then we have something that's a little bit bigger than 15.5. So I'm going to put it, approximate here. Let's really zoom in on it. Oh, yeah, that looks good. All right, 15.625. All right, what other consideration can we make? How about the possibility of horizontal asymptotes in behavior, stuff like that? That's where what happens when x approaches positive or negative infinity. We're going to take care of that with a limit. Limit as x goes to infinity. It's 5/3 right up here, right? And then 5x to the 4/3. Okay, if you were to stick in infinity right about now, this would still be infinite, this would still be infinite, and you would get 0. No, you get infinity minus infinity, which is indeterminate. No, and you cannot take L'Hopital's rule on it because it's not 0 over 0 or infinity over infinity. So what do? You got to fix it. You're going to fix this one by factoring? Sure, why not? And you know what? We've already factored this. We know it factors as x to the 4/3 times 2x to the 1/3 minus 5. Okay, so now let's check it. On the outside here, this is going to be a positive infinity. On the inside here, this is also infinity. Square root, or the cube root of it, times 2 is infinity. And then we're subtracting 5 from it, still infinity. Infinity times infinity is infinity. Okay, what's that mean? No horizontal asymptote. It means the right side of our graph is going to go upwards. This is in behavior. Okay. Let's do the same thing for negative infinity because maybe it changes. So the limit as x approaches, in other words, maybe it's, a disco dancer versus a referee, negative infinity. I'm going to put it in the same exact kind of factored form here. X to the 4/3, 2x 1/3 minus 5. Okay, and let's do the same kind of sign analysis. If I plug in a negative infinity here, it doesn't matter that I'm taking the cube root, I'm raising it to the 4th power, so this part is going to be positive. On the inside here, taking the cube root, it's going to preserve its negativity. Multiplied times 2, it's still negative, minus 5, it's still negative. So this one is a positive times a negative. This one's going to go down to negative infinity. Boop. That means the left side of the graph goes downwards. Okay, all right then. Let's see, let's do perhaps one more thing. Let's talk about its symmetry, its possible symmetry here. I don't know. If you take a look at the graph grid, doesn't look very symmetric, but maybe we're wrong. So to find its symmetry, possible symmetry, just plug in a negative x and see what happens. So I have 2 times negative x to the 5/3 power minus 5 negative x to the 4/3 power. Okay, so this one is raised to, the first term's raised to the 5th. Cube root doesn't matter. It preserves the sign, and so does the 5th. It preserves the sign, so it's a negative 2x to the 5/3. Okay, and then on the second term, it's going to get neutered because we're raising it to the 4th power. This is going to be positive minus 5x to the 4/3. If I compare this to the original function, it is not equal to the same thing, and it's not equal to negative f of x either, because only one of the signs changed, not both of them. What's this mean? This means there's no symmetry. No symmetry. Not the even type, not the odd type, neither one of those two things. All right, so in the next video, I think this is enough for this one. We'll do the calculus side of it. I mean, it's not like we didn't do any calculus like right here, but we're gonna do a little bit more.